So what I do here.
Okay, we're on the air.
Do you number 25?
I'm going to start with 26.
No.
You really want 25?
Yeah, 26 is good. 26 is good. 25, sure.
25.
Oh, yeah.
All right, we have special request for 25. 25 is a hair on the harder side. Leon,
What?
tell the audience to be quiet.
Be quiet, be quiet, be quiet, be quiet.
Start naming names here.
Okay, name. I
On
can
the
do
air.
that.
All right, number 25, they gave you the f of x, and they say that the g of x is the inverse. So I'm going to get the f of x and the f prime of x a minute over here. You got to make sure that camera is good all the time, Leon, so that they can see stuff.
Okay.
Okay, maybe might move it a little bit once in a while.
Oh, yeah.
Oh, she's good. That makes this a 9 then? That was a correction by the Ever Alert, Kiara. So the first derivative would be 9x squared plus 5. Now they're asking about the g prime of 8. Remember, inverses swap the x for the y. So we are really kind of interested in both the x's and y's and swapping them. If the x inverses reflect right across x equals y. So if the f prime of x goes like 9x squared plus 5 and goes sort of like this, that would be a typical 9x squared plus 5 graph. That's an x squared graph, stretched thinner and raised up 5. The g of x, g prime of x would go like this. You understand? They not only do the originals reflect across here, so would the slope graphs. And since this is an 8, we are interested in what x of the original could give you an 8. I'll write it out, but you could start thinking about it. It's easy enough that some people can guess it. Can you imagine an x inserted here, a value for x? Can you imagine some value of x put in here that would give you 8? If you can't see the 1, that's not crazy, abnormal. You could always get it with the quadratic equation, which would be a little more work. But anyway, it really helps if you can see that a 1 for x would give you 8. So we put that 1 in here, and we get the point 1, 14. It's not at all to scale, but I'll just put in 1, 14. That means the slope of the original at that spot will be 14. But we're not interested. We're interested in the slope of the inverse. Well, that'd be over here somewhere where x is 8. We're trying to find the slope there. Well, if the slope here is 14, the slope here is 1 over that. Because these slopes, think about it, if this is going over 1, up 14 right there, you're not getting close enough there. If you're going over 1, up 14 real steep here, reflect that over to here, and it's going up 1 over 14. So the answer is going to be 1 over the f prime of 8, which is going to be 1 over 14. You asked. I wasn't going to do that one. 26, I feel is very doable. The key to 26 is to see that you can rewrite that. You can just take x into each of the top things. You can easily rewrite that as x squared minus x plus x to the minus 1. The integral of that is going to be, this goes out to x cubed, so you got to do a 1/3 in front of it. This goes up to x squared, so you have to do a 1/2 in front of it. Plus, you have to remember that you can't do that up to a 0. This is a 1 over x. You have to have memorized that the integral of 1 over x is ln x. And then you always get your ubiquitous plus c. Looks like E.
Why is that two values?
There's the question.
Why is that two values?
Because you can't take the log of a negative. All right. Was it C? E? E. It was E. Next. Oh yes, 27. By the way, the reason you're watching real close on these is so that you can do one like this now after having seen it. That's good practice even if you didn't get it the first time. Some of you almost got it the first time. And this one, for instance, should be piece of cake now the second time. 27. 27 has a picture or a graph with it. And I got to remind you of some of the things that you learned. They have like a curve F and a curve G. And we're looking at it between A and between B. And we're trying to describe area R in there. We want to come up with a value for area R. The thing I think you know is that this area right here, which I am dotting, if you do an integral from A to B of function f, you will get this area and the answer will be negative, right? So if you put a minus in front of that, then we would say this expression right here would give you that dotted area. So you're going to have to negate, unminus it or negate it. Then if you wanted to do the integral of g, you should understand that's going to give you this area, the one I have cross-hashed there, and that's going to be negative. So if I put a minus in front of it, it'll give you the positive area that I have drawn lines across. So R would be this one minus this one, right? So I'm going to go a minus that, and then subtract the other one. So this would technically give you area R. This shouldn't throw you if I do this. And I think that if you do negative the G1 and positive the F1, I think most people can see that's going to be equal to this, the f minus the g, because the g one will have to be subtracted out. So I think that is choice 2. 1. That's choice 1. So we like choice 1. Now the other thing you need to know to get this one right is that if we swap A and B, that's doing it exactly backwards. You'll get exactly the opposite answer as if you would have done it the other way. Just remember, pan up here. If we do like a little thing here and we do a 0 and a 1, we take the top one minus the bottom one. If we switch that around and then we do the bottom one, that makes it exactly opposite, you understand? So if they swap A and B, that's like negating it. And swapping these two, the F and the G, would do the same thing, right? So if we do a double swap, we'll be back to where we started. So we like 1. Choice 2 is a single swap, so choice 2 is bad. Choice 2 is exactly the opposite of what we want. Choice 3 swaps 2 things, so it's bad, bad, back to good, you see. So we like choices 1 and 3. Which option is that? That would be D. So that was kind of a easy one to make a little mistake on, but yet I think you can get it now. Get that one out of the way there, Leon. I'll just leave that. Get that one out of the way too, Leon. All right, we're going to 29 now. Wait, 28. No, we did 28. No, we didn't do 28 yet. We can do 28. 28 isn't too bad. In 28, they want to take that region R and rotate it about the line y equals 1. Can you bring me back my sketch? Leon's got a lot to do today. I think that's good. In 28, they're talking about taking this area R and rotating it around y equals 1, which is way up there. That's going to make a hole. I hope you can see the hole. If you rotate this around y equals 1, the hole is going to be as big as it is to F and 1 bigger, isn't it? So I think the important thing to see here for number 28 is that your hole has got to be the opposite of F, because F is negative, plus 1. That's going to be like, that's equal to the radius of hole. F is negative, so minus F gives you this distance right here. A minus F plus 1 gives you the full distance for radius of the hole. Then the radius to the outside is going to be 1 minus g with the same kind of thinking. That'll be the large outer radius. Now if you take a representative slice here, and you rotate that around y equals 1, you're going to make what they call a washer, or a cylinder with a cylinder hole out of it. So the shape is going to look like this. We did do a few of those, and we learned that the equation is going to be cylinder minus cylinder, which is pi r squared h minus pi r squared h, and the tiny little change in x is your h. So we can cover this by doing a whole bunch of infinitely thin slices from A to B. We can take the pi, set it outside, is what's usually done. And we really inside here just need r squared minus r squared. Can you see that if we put the 1 minus f in the place of the little r for the whole, and the 1 minus g in place of the big R for the outer radius, I use R for outer radius, not to be confused with the R they used for that shaded area, then the answer looks to me like it's going to be the 1 minus g squared there, the 1 minus f squared there, the pi on the outside. I'm thinking it's E. It looks like E to me. All right. Oh, we can pull out the calculator now. Leon's not going to be able to demonstrate any cool TI-84 moves for us. So
How about Casio?
Casio.
That's way much better.
Much better.
Go ahead and say it with a straight face. Say it in the microphone. We'll see if he can say it with a straight face that Casio is better.
Casio is way much better.
Look at that. He couldn't even look at the camera.
I'm scared of camera. I'm Asian.
Scout?
No, I was waving at the camera.
Gee. 29. The curve secant over x plus 2 passes through the point 0. Then use the equation of the tangent line. I think we want to do a derivative here, kids. You know how I like to just not use the quotient formula. I like to just use the product rule. This is the derivative of secant tan. So I think the derivative of the whole thing is going to be like that. And it looks like we're interested in the derivative at the point 0, 1/2.
You can get the negative 2 from it. That means it's better.
I was doing a fix, but I should not have.
You did it right, Mr. Bull.
I did?
Yeah, because you took the -1 times the whole thing.
Yeah.
Ooh,
Oh,
yeah.
wait, just-
That's not
So
right,
just
because it'd
be-
be
it's
times
gotta be
1.
negative.
-1, right?
It would be +1, isn't it? Just the x in the
Well-
middle? So you just don't use.
Yeah, so it's not a fix. I should not have done a fix, but when you do a derivative with the power, you got to take that power times it. So I think I get a -1. For instance, if you have 2x cubed, you got to times that in there and you get a 6. So I should have done that with the -1. So I think Chris called that.
And Chris would probably-
Both Chris's helped me.
and then Chris is-
Is it good now? You guys like it? Tell me if I'm still messing up.
Would it be negative x minus 2 then?
No?
Because it stays the same.
Yeah.
You're treating that whole,
I'm treating the
You
x
could put
plus.
it in, but you don't have to.
Well, I don't know if you should with that 2 up there.
What are we doing with
Well,
that?
when you did the original, the derivative originally,
What do we do with the negative?
yeah, you didn't
Is it
really,
just hanging out there?
It would be
Didn't really,
minus
uh,
secant x.
didn't really multiply that.
Yeah, well, I did that instead of a minus there, so,
It's the same thing.
yeah. Yeah. So anyway, this is at the point where x is 0, so this looks like a big mess, but I can throw a bunch of zeros in it right away. First of all, the secant is 1 over cosine, so that's going to be 1 over 1 times the tangent at 0. I think the tangent of 0 is 0 because it's got sine on the top. So this whole part is out. I have a 0 there, so I don't even care about that part. Only the back part here. So that's still 1 times 1 over 2 squared, 4, and then don't forget the minus, whether I put it there or there. So it's going to be equal to minus 1/4, right? So the slope at the point we're talking about is minus 1/4. Now if you're thinking about this graph, we already know the graph goes through the point 0, 1/2. And apparently it goes through the graph at that slant, down with a 1/4 down slope. That would be like over 4 for every one down. So as we as we try to decide where it'll hit over here at the point 1, this point right here is going to be 0.1 to the right, and then it was at a height of 0.5. Shouldn't it, if it goes 0.1 to the right, shouldn't it go down 1/4 of 0.1? 0.025. So I think it's going to be the 0.5 that it was at minus 0.025. Its new height will be 0.475. That'd be choice B. Now I feel like there might, if you're good with your calculator, you maybe have gotten this another way.
Yeah, for sure.
How did you do it, Caden?
I plugged it in, and then I plugged in the derivative of it and found what the slope was at that point in time. And then I plugged in the y or the p as well, and then I plugged in 0.1 in that new equation. And I got 0.475.
I did an even better way, Katie.
Scott will now describe his way.
Well, I looked at the graph,
Yep.
and I went to my table without going to the derivative. Whoa. Saw where it was at 1/2, and then I saw where it was at a tenth past that, and I saw that it was like 0.2 higher or something like that.
Didn't have to zoom in that much to see that only one of these choices could be it.
Simple logic.
All right. All right, so I taught them more than they needed to do this, Leon, if they know how to run a calculator. Can Casio do a problem like that?
Oh yeah, easily.
All right. It's so easy it can be done on a Casio, he says.
Yep.
He's making fun.
No, Casio's the best.
Yeah, I love the Casio. He's just mad because he doesn't get color centers. Calculator.
Number 30. If f of x is equal to the inverse tan of x, they're talking about the rate of change of it, so I think I want to do a derivative. Caden says he can just do this on his calculator.
Do I need to do anything about those? Just leave it.
Oh no, I'm just going to keep those, I think. Is it 1 over 1 plus x squared?
Yeah.
Some people may have that list nearby. Yeah, I think that's what it is. And they want the average rate of change from -1 to 0. So if you're graphing f from -1 to 0, we have to get those 2 points. Now this can be all figured out with unit circle and stuff, or since you're allowed your calculator, can't you just do an inverse tan? I'm going to have Caden do the inverse tan of, well no, it's not the inverse tan, Caden, I take that back. It's going to be this with a, I don't think I even need his help. If I put a -1 in there, it's going to be a half. If I put a 0 in there, it's going to be 1. Right? So you picture on this graph going from a height of a half to a height of 1. Now it doesn't go straight. But we want to know the average rate. When will the instantaneous equal the average rate of change? In other words, we want to know at what instant is this graph at a slope of what looks like a half. So you can just graph this and try to find out where the slope of it is, where the height of it is a half. No, 3/4, right here, halfway. This is another one that Scott could do with less work because there aren't that many real close choices. I wonder if I can pull this up.
So what is the answer?
No. Can they see? They can see that, right? So,
They can see it.
yeah, but you should record it for them.
Oh.
Then they can see it when they go home and look at it again. So the blue one there is the graph of the first derivative. And we're talking about what it does between that spot and that spot. Well, the slope from that spot to that spot, straight line slope, is a half. Or another way to look at it, it goes from a height of 1/2 to a height of 1. So the average height in there is 3/4. So we got to go find where it's 3/4 high. I'm going to start zooming in now. we got to find out where is it at a height of 3/4. Right here would be a height of 3/4. It's a little bit to the left of a half, isn't it? So you got to pick an answer that's a little less than negative 0.5. There's only one appropriate choice. B. $31. I think 31's an easy one that you want to put on your short list. Oh, we got to get this out of the way now.
You gonna do 31?
You ready?
Yep.
You're gonna move that back. Yeah.
All right, you ready, Leon? We want to talk about the area under the curve of y equals kx squared. So if this is the curve of kx squared from 0 to k, the way you would find this area under the curve from 0 to k is you would just do an integral from 0 to k of the formula for the top of it, kx squared, deriving on the x. If you do that, you're going to go your x up to x cubed. The k is just a number that we don't know. It's not a variable, so that'll stay right in front of it, but there's going to be a 1/3 happening, right? But we have to keep that k in there. So it's going to be times k yet. And it'll be plus some constant, but that's going to cancel out when we do this. So we've got to put k into this. So it's going to be 1/3 k cubed k minus 1/3 0 cubed k. Isn't that just going to be end up being 1/3 k to the 4th? You're going to have k cubed times k, that's k. So I think it's pretty easy. Choice C.
Is that A?
That's A.
Oh, A. $32 and $33 are about the same formula, so I'm going to do them both right here, Leon. First of all, d squared minus 400d plus 160,000. That is sales per day, where T is the day, days numbered from 0 to 365. And to get the total from 0 to 31, just remember, if you did a chart like this and you put these sales as dots on a graph and graph the height as the number of sales, 365 dots, and you wanted the total from 0 to 31, that's an area. So you're just going to do this. And you're just going to put this formula right there. And I think your calculator can do that, can't it? I mean, we could do it by hand too. It isn't that tough. But I think you can just do an FN integrate with that formula in from 0 to 31. And if you do that, what number do you get? A? People tell me they get A. Then if you want the average per day, you divide it by the width, which is 31. So this little part gives you answer for 33. Just divide by 31 to get the next answer. Before you divide it by 31, you got the answer to number 32. Sounds confusing. Number 30.
Brother.
Oh. $34. First of all, realize what kind of a graph or function they're talking about. If they say the f of negative x is equal to negative the f of x, that means if you put in an opposite input, you'll get an opposite output. So if the f of 2 is 3, this graph goes through the point 2, 3. It's also going to go through the point negative 2, negative 3. This graph could do something like this. Remember, x cubed was one that did that. There were two kinds, the even and the odd. If the f of negative x was the same as the f of x, it went like back up and it was symmetrical left, right, and we called it even. If it was exactly opposite, then the graph was pivoted down and the upper right is exactly opposite of lower left. So we have the odd function. That's the first thing that you have to notice, is that they're saying we've got an odd function. And then they're saying over here they're saying the f of 2 is 1/5, a slope of 1/5 right there. Wouldn't that be the same as the slope of negative 2 over here then? Because this part of the graph can just pivot right over on the other part if it's an odd function. So we're going to write an equation using the point slope method. That's that style. That's one of your extra credit equations that you might memorize. And that's the style of it. Since it's the same slope, we think we're going to put a 1/5 here. Well, that doesn't exactly narrow it down, but a little bit. Then we're going to make sure that it goes through x equals -2, because they want to do it at x equals -2. So that means you have to have a -2 right there. Oops, I put that in the wrong place. Leon, you should have stopped me. X is -2. And because it's an odd function, if the f of 2 is 3, the f of -2 would be -3, so we're going to put a -3 here. So I think we're talking about the y plus 3 equals 1/5 x plus 2. Does one of them look like that?
Yep.
Which one is that? Take E. The key was knowing what odd functions do. Ooh. 35. We're going to take the graph of ln of x, which I think goes something like that. And we're going to look at x equals 5, which goes like that. And we're going to rotate this region around the x-axis. Well, each little representative rectangle of that will be a cylinder. So I'm thinking pi r squared h. To get a whole bunch of wee little h's, you're going to have to do this. And they go from 0 to 5? No. If you look at your graph of ln of x, I think it starts at 1. And right here, the radius of every slice will be the y, which is this ln of x. Don't forget to square it. So I'm thinking of an answer that looks something like this. All you have to do is punch that into your calculator, hopefully. Oh, Kiara saved me again. Pi. Don't forget your pi. Which one is it? 80.
C. Yeah, I got C.
People are saying C. $36 should be on your short list. Pretty easy. Goes from 0.4 to 1.7 to 2.8 3.12 4.15 5.22. That should be higher, but it doesn't really matter. 6.26. They say they want this divided up into 3 equal subintervals. Well, that's 1, 2, 3, 4, 5, 6 spaces. So if we divide it into 3 even subintervals, our slices are going to look like that. And then we're not going LRAM or left to decide the height. We're not going right to decide the height. We're going middle. So we're really going like this, this, and that. We never even use half of these figures. So the width of each of these looks like it's 2. So I think you just need to go 2 times your odd numbered heights. 7, 12, 7 plus 12 plus 22. Nah. What is that? A? B. What time is the period over?
Just hit 45.
37.
here that is gradually getting bigger. And they're talking about this moving like a clock hand, I believe. And it takes 30 seconds to go all the way left to right. They're talking about this angle being measured in rads or radians. And their first question is, how fast is the angle changing in radians? Well, it takes 30 seconds. The total change is pi radians. That can be the answer right there. Pi radians per pi 30th rads per second. So that's your answer to A. Pi 30th of a rad per second is how fast that angle is increasing. Then they ask, how fast is y changing? Y is the angle up here. Can you see that y is, if you're connecting to the third side there, can you see that y is gradually getting smaller? Because this one's getting bigger. And since these are both radii, you're going to always have an isosceles triangle with the top angle getting bigger. Well, it's got to stay total to 180. So these two angles are getting smaller half as fast as that one's getting bigger. So I think your answer from B is going to be decreasing pi 60ths rads per second.
That's impressive.
Is that one of those things that seems easy after you hear it?
Yeah.
I mean,
Did someone with that?
I mean, that's what I thought, but I didn't get it like that.
Yeah, I got it totally good.
Shut up, man.
Then it says S and X are related by the law of cosines. They have S over here. They kind of gave you the law of cosines and the whole formula. They said that S squared is equal to 200 minus 200 cosine and X right there. They kind of gave you that. And then they want to talk about rate of change. Well, this is where you should do that implicit derivative and do 2s derived on s equals, that 200 won't matter. The derivative of negative 200 cosine would be minus, the derivative of cosine is sine, so it's going to be plus, isn't it? Sine 200 sine x. Did I do that right, Leon? Dx. We can slap dt's under those. Put a clock on it is what I call it. This is the one that we decided was changing pi 30th rads per second. This is the one we're trying to find. They want to know this at the moment that x is pi halves. What's the sign of pi halves? 1. So we have 200 times 1 over here on the right side. And what is s at the moment we're talking about? Well, we could get that from this equation.
cosine of pi halves is 0, so it's just going to be the square root of 200. So the change in s with time is just going to be equal to 200 pi on top, 30 on bottom, and then this will come over on the bottom, 2 times square root of 200. You just have to figure that up. That will be your answer to C. And then you have to show that the area is largest when x is equal to pi halves. Well, the area is just going to always be 1/2 base times height.
What is the measurement on C, like a label?
That's a good point. They like labels on that. It's how fast this is changing right here, which they say is in centimeters. So Christian has a good point. We got to put centimeters per second on that. Seconds is the time. Centimeters is how s is measured. And I think I don't have time right now to finish the 1/2 BH. So. I need to give you second half of number 2. I think some people could probably do some of that and come out looking a little better here. Did you give them all that already?
Which part? This part?
You gave them the...
Yeah, I did.
Okay. Leon gave you the second half of problem 2. Take a look at that for tomorrow. See if you can do anything with that.
Oh,